Good morning, week 3 of coronavirus. Let's do this. So just a little heads up on what we're doing this week. We are going to work on graphs and quadratics. You're going to see why we did some factoring stuff earlier. You're going to understand what the zeros mean, and that's going to come together. I do not expect you guys to match this by the end of the week. However, it is a complicated skill, so I want to make sure that I spend as much time practicing this as possible. And make sure you show up to the Q&A sessions between 12:30 and 1:30 so I can answer all your questions and tailor my teaching to what you guys need. So just for basics, and by all means press pause to write this down so you have this in your notes. I want you guys to understand that we're graphing quadratics. You already know how to find two of these points when it's in an easy format. So first off, the standard form of a quadratic is ax squared plus bx plus c, okay? And the shape of a quadratic is called a parabola. Now, here are two different types of quadratics. One that's facing up, one that's facing down. This would be considered for the sake of argument, this is y equals x squared, whereas this one is y equals negative x squared. All right, upside down means this coefficient, this a is negative. Right side up means this coefficient a is positive. That's all you got to know. All right. Now, you've been working on factoring quadratics to understand how to find the zeros of the function. And those zeros are considered the x-intercepts, but they're also considered the solutions. Always consider the solutions, okay? What we're working on today is finding the vertex and solving the quadratics. Now, you've solved the quadratics before in easy format factoring, and I'll go through that in just a minute. However, it's going to take a different turn, and I expect there to be some, or if not a lot of confusion, which is expected. So do not feel overwhelmed because we're going to spend all week doing this. Again, the vertex, when this is a right side up, is considered the minimum because that's the lowest point that this quadratic will go. And again, wherever the parabola crosses the x-intercept, the x-axis, the x-intercept, those are considered the zeros or the solutions of the quadratic, always. And again, the vertex is now up here, so this is considered a maximum, okay? And I have this dotted line going through each quadratic. This is called the line of symmetry because this point and this point are considered equal distance away from this line of symmetry. And you guys have already been doing that when you guys found the zero of the function when we graphed the quadratic, and then you found the symmetry on the table for point tests, if you remember that from a couple weeks ago. Again, your vertex, the x value of the vertex is considered the line of symmetry. The x value of the vertex is considered the line of symmetry. So now let's get into what we're doing this whole week, which is called completing the square. And this all helps you find the vertex. What we're doing today is we're figuring out how to find the vertex of any quadratic. And it's kind of easy, but it's going to be a little confusing at first. So here we go. Completing the square to find vertex and solutions. Now, I'll go through this, start easy, go hard to make this make sense for you, okay? In today's worksheet, it doesn't tell you to find the vertex, but I'll put that in the instructions to also find the vertex as well as the solutions. So let's go with something easy, such as x squared plus 8x minus 9 equals 0. Well, this one is easy to factor, and I purposely chose this one, and again, I'm going to get harder. Because this one's easy to solve for the solutions, because I know negative 1 times positive 9 is negative 9, and negative 1 plus 9 is positive 8. So if I were to factor this, I'm going to have this be x plus 9, x minus 1 equals 0. So I know the solutions, the two answers that make this quadratic equal 0, if x equals negative 9 and if x equals 1. we have found our solutions, okay? And always, whenever you see a quadratic, if you can factor it, it's the easiest, most efficient way to do it. By all means, do it. But now let me show you the process on how to complete the square, okay? Because now we're going to use one method to both find the vertex and to solve it. And to prove that we factored it correctly, the solutions we get from this must be identical to this. This is -9. I made a mistake. So this is x equals -9. At -9 and +1 are solutions, okay? Now, here's how you complete the square, okay? So you write down x squared plus 8x, leave a space, leave this right here, okay? Now, here's what I want you guys to recognize. This is always going to be plus a number. This is always going to be minus whatever I bring in, and I'll show you what I mean, okay? So here's what's going on. Here's how you complete the square. You take half of your b, okay, and you square it. So the one rule, take half the b and square it, okay? Take half of the b and square it. So whatever half of 8 is squared, well, half of 8 is 4. Squaring 4 is 16. Think about this. I brought a 16 into this equation that was not originally here. So in order to make this function be identical, if I bring a 16 in, I must take a 16 out, okay? Now, why did I do that? Because now I can look at this as a perfect square, and this gets reduced down to x plus 4 squared, okay? -9 minus 16 is -25 equals 0. Now, why did I do all this? Because now I have what's considered vertex form. Vertex form, okay? And the vertex is always, I messed up my notes. Where am I at? There I am. No, that's not it. So your vertex form is always like this. F of x equals a times parentheses x minus h squared plus k. So the vertex is always the opposite of this and whatever this is. So the vertex is considered h comma k, because that would make this inside here. The opposite of this comes right here, whatever this is comes right there. That's the vertex. So the vertex of this particular quadratic is going to be -4, comma, -25. And I'll draw the shape, the general shape of this graph in just a little bit, just so you understand what this looks like. But now that I found the vertex, I want to find the solution. And again, the solutions have to be equal to -9 and +1 to prove we did it correctly. Now you don't have to do this every single time, I'm just showing you so you know how to do this. So if I'm finding the solution, I gotta solve for x. So I'm gonna add 25 to both sides. X plus 4 squared equals 25. Now I just do the inverse of squaring something, so I take the square root. Alright. Now, here's where you gotta be careful. You know that you need two answers. Now, I know the square root of 25 is 5. But I know that there are two ways to get to 25. I could have done 5 squared, which is 25, or I could have done -5 squared, which is also 25. So I always put this plus or minus over here, okay, always. So now this says x plus 4 equals plus or minus 5, okay? So now to solve for x, I subtract 4, so x equals -4 plus or minus 5. So that means you're really doing two different equations. X equals -4 plus 5. You're also doing x equals -4 minus 5. So there's two different solutions here. Well, -4 plus 5 is 1, and -4 minus 5 is -9. So we have just found the zeros and the vertex. Now, why is that important? Because later this week we'll be graphing all this stuff. Right now we're just solving by finding the vertex and solutions, because when you have 3 points on a quadratic, you can graph it. Now that I've identified my two zeros and my vertex, graphing this becomes much easier. All right, now we're not graphing today. I'm just showing you guys so that you can see where we're going with this. So remember, my zeros were -9 and +1, and my vertex is -4, -25. Now, if I were to graph, I'm not going to worry about graphing this perfectly. I just know -4, -25 is somewhere over here. All right, good enough. And I know my zeros are at -9 and at +1. Now, visually, this is not, just so we have a general idea of what this graph will look like. Again, based on what I did earlier, this is the vertex or the minimum, okay? These are my two zeros, my solutions, okay? Let's do another example. And we'll go from here. So, now let's do one more easy one, and then I'll do a couple challenging ones, okay? Let's say I had x squared plus 8x plus 12 equals 0. Let's just say we're doing like this, okay? So first things first, I look at this number. All right, well, you know what, let's change it up. Let's do 7. Okay, let's do 7x here. All right, so now that would be too hard for what we're doing today. Purpose. Let's change this to, let's do 10x plus, let's say 16, okay? Here's why I'm doing this. So now, again, the first things first, I write down these first two terms, I leave a space, all right? I bring this guy over here, plus 16, he stays. I take half of this number and square it. Half of 10 is 5, 5 squared is 25. Remember, I brought a 25 in, I must take a 25 out, okay? So now, let's write this into factored form because this is a perfect square. This now says x plus 5 squared, because remember, when I do this, this will make this perfectly, because again, if you're confused, x plus 5 times x plus 5, when I do FOIL, I get x squared plus 5x, which makes 10x, plus 5 times 5 is 25. That's why this becomes this. 16 minus 25 is -9 equals 0. Okay? Now, I just did all this work because now I know my vertex. My vertex is the opposite of this. So this is -5, comma, -9. Okay? But now let's go one step further and solve it. Okay? I'm going to add 9 to both sides. So I got x plus 5 squared equals 9. I take the square root of both sides. Remember to do plus or minus here. So now I got x plus 5, because that gets rid of the square, equals plus or minus 3. Okay? Subtract 5, x equals 3, -5 plus 3, x equals -5 minus 3. So my two answers are my solutions, or my zeros, whatever you want to call them, okay? X equals -5 plus 3 is -2. And remember, -5 minus 3 is -8. There's your two solutions, okay? So we're just finding vertex and solutions. Now let's do one a little more challenging, okay? So, do 2 more examples, then we'll call it quits. Just so you guys know where we're going with this. All right, let's say I have this. Let's say I have x squared minus 10x plus 26 equals 8, okay? Now, I can't start doing this one because in order to solve anything with completing the square, I need my answer to be equal to 0. So all I gotta do is subtract 8 first from both sides. So now this says x squared minus 10x plus 18 equals 0. Now, here's why we are going to be doing it this way, okay? Well, again, why completing the square is another way to solve a quadratic, because this one does not factor cleanly. Like we've discussed in the past, not every single quadratic factors cleanly. Like there's no two numbers, integers that multiply to 18 that also have the negative 10. So again, this is another way to solve a quadratic, but we're doing both, solving and finding the vertex. So same process. We do x squared minus 10x, bring this plus 18, don't forget that. I take half of negative 10. This is always going to be a plus no matter what. This will always be a minus no matter what for now, okay? So half of this is negative 5. Negative 5 squared is 25. I brought a 25 in, I must take a 25 out equals 0. Now this is factored down to, remember, now this is x. Half of this was negative 5 squared. 18 minus 25 is negative 7 equals 0. So our vertex is the opposite of this, so this is going to be 5, whatever this is, negative 7. Now let's find our solutions, okay? So solve this just like we've been doing. Add 7 to both sides. X minus 5 squared equals 7. Square root of both sides. Again, don't forget to do your plus or minus. So now this says x minus 5 equals plus or minus square root of radical 7. Leave it in radical form because it's not a perfect square. Leave it alone. Don't make your life any more difficult than they have to be already. So now just add 5 to both sides. So your final answer here is going to be written like this. Your solutions are x equals 5 plus or minus square root of 7. This accounts for both answers because I got the plus or minus right there. That answer is good enough for now, okay? One last example, and then you guys can do this on your own. Hopefully this is making a little more sense. Your practice today will help solidify any questions you might have. Let's say I got one like this. X times x minus 4 equals 8, okay? Now, I can solve this one a number of ways, but I just want us to stay on track of following this process and format so that we know how to find vertex, because that's where we're going for the end result of this entire lesson this week. So first things first, you should get the x out on both. So now this says x squared minus 4x equals 8. And again, I need my quadratic equal to 0 to solve. So subtract 8 to both sides. This now says x squared minus 4x minus 8 equals 0. Now I have it in a form that's going to be much easier for me to use completing the square. So let's go. So now this says x squared minus 4x, leave a space, bring down this 8. I know I'm adding something here, I know I'm subtracting something here. Well, half of negative 4 is negative 2, negative 2 squared is positive 4. I brought in a positive 4 to this equation that wasn't there originally, I must take it out, equals 0. So now when I write this in factor form, I look at these three numbers right here, these three terms, and I write it as x minus 2, that's in minus 4, this must be minus 2 squared. Negative 4, negative 8 makes a negative 12 equals 0. So my vertex of this given quadratic is 2 comma negative 12. 2 comma negative 12. Now let's solve this, okay? So let's solve this. I'm going to add 12 to both sides. I got x minus 2 squared equals positive 12. Square root both sides. Now, we did some stuff in the past with simplifying radicals, and I'm hoping you guys have not forgotten that because that is going to be a crucial skill throughout this entire unit. And if you want me to go back and do some more practice with this, I will gladly do that for you. So you got to remember, this radical 12 has a perfect square factor inside of it, which is 4. 4 times 3 is 12. And if you want to write it out for yourself, by all means do that, okay? Remember, the 4 comes outside as a 2, and then we can go from there. So now this says x minus 2 equals 4 comes outside as, remember, plus or minus 2 radical 3. Because the square root of 4 is 2 that comes outside, the 3 is not perfect, so leave it inside there. Last but not least, just add 2 to both sides. Now I cannot add 2 to this 2 because this 2 is attached to this radical 3. So this 2 just stays in front of this 2. So your final answer is going to be x equals 2 plus or minus 2 radical 3. And there are my 2 solutions, or zeros. Throughout this week, the questions will say find the solutions or find the zeros. Please understand that that is synonymous. They mean the exact same thing. You'll get a lot of questions. Hopefully, they're generated today on this worksheet. Ask away between 12:30 and 1:30 today, and I will help you out. I will see you soon, boys and girls.